Is that working? Are we live? Did we do it? Blame Canada. Live. Okay. So, Series Kaylee, you were mentioning the escape of a supermassive black hole. We covered that on Universe Today like 2 months ago. And this is clearly a problem because I will find stories in journals and on archive and at conferences, and then we'll report on it. And then later on, NASA, 2 months later, NASA will come out with a press release, and then everybody else is talking about it. And we're like, we already covered this. Do we do it again? Or do we look like we're idiots because people forget that we already covered it? So this keeps happening. I don't know what the solution is. I prefer that we're getting the stories first, but it is a little weird that we look like we're sleeping on a story because we're not going to cover it when everybody else is covering it. I don't know what the answer is. You tell me. All right. Okay, so if you're wondering what it is that you've stumbled into, this is going to be a live episode of the Question Show. Your questions, my answers. So how this works is I've got a bunch of prepared questions that I pulled from the YouTube comments. I'll cover those first, and then I'll switch over and we'll cover your questions, and we will answer questions until I finish the hour. So I guess at 6 o'clock my time, and then I will shut down all the recording, and then we'll stick around and we'll do overtime. And that's like where we get the good stuff. That's where you get my rants and such. So when we reach the end of the show and I record my outros and all that, don't leave. Just means that we're going to shift into a new higher state of consciousness at that point. Go ahead and start getting your questions going. Nancy, Zapfan, a bunch of people here are here to help grab those questions. They'll put them into the database in front of me so that I'll be able to answer questions. If I don't answer your question, there's a couple of reasons. One is I try to put emphasis on the people who've never had a question answered. So if you've never had a question answered, then I will notice and I will try to give your question a higher priority. I might not know the answer. I'm just a journalist. I'm not a scientist. I am a clever space news mashing machine. And so, but if it's outside of the realm of things that I have reported on, then I can't give any answers because I am not a scientist. And then the last thing is if it's like really math heavy and like we would sit here and wait for an hour as we do a lot of queries on Wolfram Alpha, that might not be the most entertaining way to spend the day. So go ahead and put in those questions and we'll get cracking. Let me start all my recordings. And that one. All right, here we go. Hey everyone, welcome to the Question Show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops into your brain, just write it down in the YouTube comments, and then I will gather a bunch of them up here, and I will answer them. But also, we do this show live every Monday at 5 p.m. Pacific time. So if you want to get follow-on questions, if you want to chat with the other members of the community, go ahead and join the show every Monday at 5 p.m. Pacific time. I will have an event somewhere around here on my channel, and so you should definitely go and click on the notification bell so that you will be reminded when the show is going to go live. All right, let's get into the questions. Sin 6 Grim Reaper. Jupiter is a gaseous planet. What would the size of the biggest rocky planet be, excluding hydrogen and helium? All right, just grab my notes. Do I have it? Okay. Okay. I got this question a ton. Like, people wanting to know biggest rocky planet. It's funny. So the biggest rocky planet that astronomers have discovered so far is a planet called TOI 849b. And there is a bunch of information in there that'll tell you it is a TESS observation. So it was discovered by NASA's TESS satellite. And it is B. So in other words, that is the first planet that is orbiting around the star TOI 849, which probably has another name in another catalog. So the planet has 40 times the mass of the Earth. 40 times, which is crazy. But the planet is 3 times the size of the Earth. And it is a rocky planet. Like, based on the density measurements that astronomers were able to make, it seems to have about 3 times the mass of the Earth. Sorry. Based on the observations that the astronomers were able to make, has about 3 times the size of the Earth. And I'm sure you're wondering, like, what would it be like to be a creature that lives on the surface of that world? And the answer is that, let me do this again. All right. And I'm sure you're wondering, what would it be like to be some kind of creature that lives on the surface of a world with 40 times the mass of the Earth? And the surface gravity of the planet is about 3.3 times the mass. And the surface gravity of the world is about 3.3 times the surface gravity of Earth. And so if you were standing on the surface of this planet with 40 times the mass of the Earth, you would still be experiencing 3.3 times the force of gravity. Like, that would be hard for you to walk around, but not impossible. Like, you could probably, like, crawl around. It would be tricky. How do you get a world with 40 times the mass of the Earth? And so the theory is that this was once a gas giant, and it had its outer gaseous layers stripped away by its star. It orbits very close to its star, and all that remains is the rocky core. And it might very well be that many of the larger, more massive rocky planets that we find out there have gone through this same process. Okay. All right, let me get the code. All right. Now, I'm sure you've noticed the Star Wars Planet Code that's popped up above my shoulder, and this is a way for you to vote for the questions that you think are the best in this episode. And the winner, again, by a landslide, was from Jason. What is the theoretical size of a planet? And I guess that was the first one we answered. And so this is great. Actually, as I time talking about that in this episode, and then I guess this will be like our new Lagrange point. So anyway, congratulations to Jason. Congratulations to me for the answer. We made a great team. So remember, watch the whole episode. You'll see the planet names. In the end, post the planet name for the one that you thought was the best in the comments down below. We'll add them up, and we will celebrate the winner next week. All right, let's move on with the questions. Baby Maker. What about an iron planet? How big could an iron planet get before collapsing into a black hole, given that it wouldn't have active fusion to push out? I would guess that it would be less massive than an equivalent star. All right, so there's a bunch of pieces working together here. The first one is iron, and you correctly noticed that iron doesn't give you fusion. And so this is one of the situations that happens with a star. When you have a very massive star, a star that is many times the mass of the sun, it is fusing material in its core. It starts with fusing hydrogen into helium, and then it has still the kind of pressure to continue up the chain of elements. When it runs out of hydrogen in the core, it starts fusing the helium together, and then it starts fusing carbon and neon, and it works its way all the way up to iron. And when it hits iron, the problem is that iron is not a net positive for the fusion process. It takes about as much energy to fuse iron as it releases. And so all of this radiation pressure that was keeping the star in this big spherical shape goes away almost instantaneously. And then all of the outer layers of the star come crashing down inward. And then you get this sort of compactification at the middle, and you also get this bounce. So you get the black hole or neutron star forming at the middle. Then you get all of the energy that's released from the supernova. And so you are taking just the raw iron, the finished product of what would be in the middle of a star that was many times the mass of the sun, and you're wondering what would happen. And so if you started out and you started piling iron up, then it would be no problem. But the mutual gravity of all of that iron would be pulling it down together, closer and closer, getting more and more dense as you kept at it. And if you were about, a little below the mass of the sun, you would end up with a white dwarf that is the mass of a ball of iron, right? A white dwarf, an iron white dwarf. And then as you got to about 1.2 times the mass of the sun, you would shift over into and you could get up to just shy of the Chandrasekhar limit. This is the phase between white dwarfs and neutron stars. And so when you cross this 1.2 to 1.4 times the mass of the sun, now the sort of pressure that's pulling inward against the atomic pressure of the iron that's pushing outward would be overcome, and it would shift into becoming a neutron star. And so you would have the neutrons and the protons getting mashed together, and you would no longer have iron. But this process would also be quite dramatic, because you would get the thing essentially collapsing down and turning into a black hole. But the part that's kind of weird is that normally when you've got this black hole forming, you've got all of this outer envelope of the star. You've got this, 10, 20 times the mass of the star that is coming inward at like 70% the speed of light, that is mashing down the core, and that helps to contribute to both the formation of the black hole as well as the explosion of the supernova. So it might very well be that the thing just kind of winks out of existence, that you don't get the gigantic supernova explosion that you would with a star. And there are objects out there that might be kind of like this. So there's a term that astronomers use called unnova. And the gist is that there was a star there, and now the star is gone. And the assumption is that now it's been replaced with a black hole. But there was no supernova in between. That at one point, the star was just sitting there, and maybe it ran out of core. The star was just sitting there, and then it ran out of fuel in its core, and then the outer layers collapsed down, and maybe it just, the way the turbulence worked or something, the way the magnetics worked, it didn't get that gigantic supernova explosion. It just all went nicely into the black hole and just turned invisible. And you just go from star to nothing. And it might be that a lot of this happens, that a large percentage of the stars out there that we would think explode as traditional supernova are just disappearing into black holes with no intervening step. So don't do it. Okay. Greg Rumscheit. Why is our moon floating away and not going to crash back down, and Mars moons are falling back down? Yeah, the Earth's moon is moving away from us at about 1 centimeter per year. And we know this because when they landed on the moon, the astronauts put down these retroreflectors onto the surface of the moon. And now you can fire a laser beam at the moon. It'll bounce off one of these retroreflectors, come back to you. You know the speed of light. You time how long it takes for the laser pulse to get to the moon and back. And that tells you the distance to the moon. And then you do that experiment 1 year later, and you find that it takes a tiny little bit longer for your laser pulse to get back to you. And you do the math, and you realize that the moon has gone 1 centimeter farther away from us. And this behavior is completely expected. And I mentioned a couple of question shows ago that it's the opposite situation for Phobos at Mars. Phobos, the moon Phobos orbiting around Mars, is getting closer and closer to Mars. And in about 50 million years or so, the gravity of Mars will tear Phobos apart, and then the pieces of Phobos will rain down and crash into Mars. And so the question really is, why is the moon drifting away when Phobos is moving closer? And the answer is the orbital time of the moon compared to the rotation time of the planet. And so in the case of the Earth and the moon, the Earth takes 24 hours to turn once on its axis, and the moon takes about 28 days to orbit around the Earth. And so the tidal interactions between the Earth and the moon is essentially causing a bulge on the Earth, and that is causing the Earth's rotation to slow down. And to sort of conserve the momentum between the Earth-Moon system, the moon slightly shifts outward as this goes. And eventually, over the long, long period of time, like 50 billion years, the Earth and the moon will lock to each other. And then the Earth will be turning at the exact same rate that the moon is going around it. And then if you're standing on the Earth, you'll be looking up at the moon, and you will always see the moon in the exact same spot in the sky. Now, that'll be after the sun has turned into a red giant and possibly destroyed the inner solar system, but if it all lasts, then that's what you'd see. But with Mars, you've got the opposite situation. So Mars takes about 24 hours, like 24 and a half hours to turn once on its axis, but Phobos takes less than 8 hours to orbit around Mars. And so the opposite situation is happening. The tidal interactions between Phobos are causing Mars to spin up. It's like Phobos has grabbed a handle on Mars and is spinning it faster and faster. And to maintain momentum in the system, the height of Phobos' orbit is coming down, and eventually it will crash. And so whenever you see this situation, if you see a moon orbiting around a planet and the moon is slower than the planet rotation speed, then you know that the moon is going to drift away. And if the moon orbits more quickly than the rotation rate of the planet, then the moon is going to crash eventually. And you'll see this time and time again. And eventually, all things want to lock to each other, like, say, Pluto and Charon, where you've got these two objects, both are tidally locked to each other. All right, those were my prepared questions. So let's move in on your questions. Let me just take a look. Observable universe. I've read that on Jupiter, even though its gravitational force is equal to the Lagrange point, L4 and L5, it's observed that more objects accumulate at L4. I think that's because it's ahead of Jupiter in orbit, but I don't remember exactly. So I apologize, but I think that's what the difference is. Crazy thing about the Trojans is there's as many objects in the Trojan fields of Jupiter as there are in the main asteroid belt. Jamie, what's your thoughts on the Rask drama? I'm not. I have no idea. I live in a drama-free life. Stephen Collins, what's the latest on the meteor that exploded over Maine? I don't know. I hadn't heard about that. Joan Furva. If you're in a spinning spacecraft that simulates gravity and you jump, do you stay floating? No, no, you, oh, this again. No, if you're in a spinning satellite that is mimicking some level of artificial gravity and you are already experiencing an outward force from your rotation around the center of mass from this space station, then you have this outward force that is going to continue on. You jump up and you will jump up for a little bit and then you will continue back outward and it'll feel just like jumping. Although it'll feel a little different from jumping because of the Coriolis effect. And so when you think about sort of the rotation rate, so you've got the space station is turning and you're on the outside and you're experiencing, say, one gravity for your feet. But if the space station is small enough, then you're going to experience maybe like say 90% gravity at your head, which is already going to feel super weird, right? You're going to be experiencing less gravity at your head than you do at your feet. And in some cases, it may make some people sick. And then you jump. And so now your feet are experiencing 90% gravity. And so you will, assuming you can jump your own height, which not many people can, but anyway, then you will kind of drift over a little bit. And so you, even though if you try to jump exactly straight up and down, you won't land where you took off, but you still will jump up and then come back down and still be on the outside of the space station. But if you were able to somehow like climb a ladder right to the very middle of the station, and then you were able to like push off, then you would be floating in the middle of the station and you would have the whole station rotating around you. But as you started to drift closer and closer to one of the edges, then you've got this moving mass of air that is turning with the space station because you're in a sealed space station. And that air will start to speed you up in the way that it's turning, kind of like a wind, and giving you that velocity. And then you will start to drift towards the edge of the station as you're moving faster and faster with the station until you sit down on your feet. Now, I don't know whether like you would fall like really quickly and die or whether it would just be this very slow drifting. If it's slow and drifting, then that's cool, right? Because you could like enter the station and then you just step off the center of the station and you drift down, float down to the ground, and now you're on the exterior of the station. So I haven't done the math on that, but this is why we need some kind of rotating artificial gravity space station to test out all these ideas, figure out like what is the minimum size where people won't get sick? What is the size that you need to be able to handle the tensile forces that we can build today? What, can you even eat food, pour liquids, play sports games in some kind of rotating cylinder? We don't know the answers to these questions. We need to find them out. So we need to build a giant rotating space station in orbit to test out all these ideas. Please. Kip Nielsen. New SpaceX video was cool. Do you think glass dome cities on Mars are going to be real? I've always thought that subterranean tunnels would be better for the radiation protection. I haven't seen this new SpaceX video that you're talking about, but glass dome cities on Mars. I mean, you don't want to say never, never say never. I mean, who knows what kind of future technology we will develop where we're able to put up glass domes that are strong and sturdy and radiation protectant and can maintain the pressure inside so that people can go out into it. There are a couple of problems. One is the radiation. And so, in fact, sort of there was a fairly recent paper that I had read and reported on Universe Today about how the radiation levels in space, like if it goes through glass, like in a greenhouse at Mars with no radiation protection, is too much for plants. So if you like build a greenhouse on Mars and you try to grow in the greenhouse, then the radiation that's coming from space will kill your plants. And so you can't just grow your plants in sunlight. You need some kind of barrier in between your plants and space. And so maybe if you have like a really thick chunk of glass, like something that's like a meter thick, whatever gets you enough protons. But like if you have like a meter thick of glass, well, that's still let the light shine through nicely? I don't know. So in terms of like growing, chances are we're going to have to grow underground using light, using artificial light, like, big LED grow lights. There's plenty of people with an expertise in this here on Earth, and I'm sure they can adapt that technology to Mars. For the people, same thing. You're going to want to spend a bare minimum amount of time out under glass. And you're going to want to spend most of your time under a meter of rock or more to protect you from the cosmic rays. And so I don't see it being feasible. Like, unless somebody comes up with a kind of glass that is incredibly thick and radiation protective, it's not the kind of risk that people are going to want to take. So, but even just in terms of simplicity, yeah, we're going to go to Mars. The first thing that's going to go to Mars will be a bunch of, I guess, Starship boosters landed on the surface of Mars. And then people are going to dig tunnels underneath the surface, and they're going to live in those tunnels, and that will be their life. You have to give me a link, Kip. I guess you can't give me a link. Transparent uranium. Tricky. Transparent aluminum. Like, it's just protons. You need protons. Kamui, Master of Disguise. Are we still looking for Planet 9? We are. The existence of Planet 9, some object that is, like, say, the mass of the Earth, maybe even the mass of Uranus, somewhere out beyond the orbit of Pluto, is still supposed to be out there based on the gravitational interactions between the various objects and the Kuiper Belt objects. This again. Some object appears to be interacting with the outer solar system. You've got the orbits of all these different Kuiper Belt objects, dwarf planets, way out far away from the sun, and they're moving in such a way that they're being influenced by the gravity of some massive object that is out there. But so far, nobody has been able to find this massive object, and they've looked. And part of the reason is just that the current suite of telescopes just isn't powerful enough and isn't wide-ranging enough to be able to scan all of the places where this thing could be. But good news, there is a powerful new observatory that's coming out in the next couple of years called the Vera Rubin Observatory. And it's going to be an 8+ meter telescope with the largest digital camera ever made. And it will be scanning the entire night sky from the southern hemisphere every couple of nights. And it will find tons of asteroids and comets and supernova. And it'll probably be the telescope that will find Planet 9. So if and when, let me guess again. So when Vera Rubin comes online and they do a comprehensive search of the night sky in all of the places where Planet 9 could be, and it doesn't find anything, at that point, I think the astronomers are going to need to go back and double check the math, make sure that they are really sure that this thing is out there, because whatever it is, it's going to have to be really small or possibly non-existent. And there are other alternative explanations for how you can get these strange gravitational perturbations to all these objects in the outer solar system. So, Vera Rubin is the machine that will find it. And if it doesn't find it, then there's a pretty good chance that it's not there. Bravo 1, does Nightbot already use ChatGPT? Not yet. We're working on our ChatGPT implementation for Nightbot. It won't be in Nightbot. It'll be straight into the YouTube API. Shravan Rowe. as we keep finding more and more dark matter galaxies, would the phrase there are more galaxies in the universe than there are stars be true? Well, I think the phrase that you're probably saying is that there are more galaxies in the universe than there are stars in the Milky Way. So the estimate is there are between 100 and 400 billion stars in the Milky Way, and it's estimated that there are about 2 trillion galaxies in the observable universe. And so based on that math, there are more galaxies in the universe than there are stars in the Milky Way. But as you're saying, astronomers are finding more and more of these dark matter galaxies. But that just means there's going to be more galaxies. Like you're going to have 2 trillion regular galaxies, which have a normal mix of dark matter and stars. Oh, I got to stop my recording. No, I'm almost out of space on my memory card. All right, let me just stop both of them. God, I noticed. Still focus? Okay. Let me see part 1 of the audio. Chad needs to add a button. Yeah. Okay. Second time this has happened. Okay. Okay. Lots more room. Okay. So if we go back to the comment that you said, right? If we find those additional galaxies that have no stars but just have a lot of dark matter in them, then there are going to be 2 trillion galaxies. Then there's going to be many more, maybe another trillion that have large amounts of dark matter in them. So no, I think there will always be more galaxies in the observable universe than there are stars in the Milky Way. Let me know if I didn't get your question exactly right. I can't believe I don't start each show with a fresh card. I pull the cards out and I upload them and then I swap them and the files are very big. I have 256 gig cards and I fill them up pretty quick. Get the editor to put this bit in the video. Yeah, Chad's watching. In fact, just by referencing it, it's going to happen. So, Kiwi Bacon, ever listened to Ween? Yeah, like a long time ago when I was like 20. So, Jamie Amendolagine. Sure, hold on. Jamie Amendolagine. I'm a longtime lurker and Canadian expat living in California. Do you recommend returning to British Columbia, maybe Vancouver Island, to retire? So for those of you who are watching who don't know, I live on the beautiful island called Vancouver Island on the west coast of Canada in the province of British Columbia. I live about halfway up Vancouver Island in this town called Courtenay. And I actually grew up on an even smaller island, which is just off the coast of Vancouver Island called Hornby Island. And if you do a search for Hornby Island, people call it the Hawaii of the Gulf Islands because it has this amazing, giant, powdery, sandy beach that you can go. But it's not warm. I mean, I guess it's warm in the summer when the warm water comes over the sand and heats up. Then it's nice. And it's beautiful here. Like Vancouver Island, Canada is just gorgeous for half the year. For half the year, it is rain and cold and pretty miserable. And then around this time of the year, like in early April, everything turns around and the sun comes out and the temperature warms up and the trees get their leaves back and the flowers come out and all the way through. And then the rain goes away. And for the next couple of months, it doesn't rain very often. In fact, we have droughts in the summer. It gets so hot and dry. And it's gorgeous. I love it. I've been in a lot of places in the world. And I'm always kind of going like, would I want to live here compared to living in Canada? And I say no. There's some things that very specific places, like, wow, this place has nicer weather than that I'm familiar with. Boy, it sure would be cool to be able to jump in the ocean anytime I wanted, as opposed to only half of the year, and other things. But yeah, you should definitely come back. In fact, like when you meet people who are Canadians, many of them have come from other parts of Canada, from Eastern Canada, and it's a one-way trip. Like people from Toronto in Eastern Canada, they come out to the West and they don't go back because it's so great out here. I always say that I live in the Florida of Canada, but it's not it's not as warm as Florida, but still, yeah, it's a great place. Lots of trees, people are nice, kind of expensive, although not too bad if you live in a more rural area. And that's where I met Chad, here in this city. It's where I met some of the other writers for Universe Today. But yeah, come on back. You can decide if you want to include that one, Chad. Marinescu Lucien, do we have a future mission to explore Europa, Jupiter's moon? Curious to see if we can meet other Europans. Yeah, there's two missions going to Europa. One is NASA's Europa Clipper mission, which is going to be launching, I think, in 2027. And it's going to fly out to the Jupiter system, and then it's going to make these big, long orbits around Europa. And one of the cool things about the Europa Clipper is it's equipped with a ground-penetrating radar system. So it'll be able to analyze the ice under the surface of Europa, searching for cracks and fissures and under ice lakes. It probably won't see the European space whales, but who knows? So it's a pretty exciting mission, and that's going to really set the groundwork for future missions that will then go. Maybe there'll be a lander to Europa, and eventually there will be a mission that's going to try to melt down through the ice and try and reach the under ice ocean down beneath, and really meet the European space whales. And then, of course, the European Space Agency has a mission called JUICE, the Jupiter Icy Moons Explorer. JUICE. And it's going to be flying past 3 of Jupiter's moons. So it's going to fly past Ganymede, it's going to fly past Europa, and it's going to fly past Callisto. And so it's going to be doing more of an overview of the icy moons, and it's going to end up orbiting Ganymede, which is kind of similar to Europa, like is bigger, has a thick layer of ice, has some kind of liquid ocean underneath, but it also has a magnetosphere, which is very different from any other place. And that is launching in a week from the day that I'm recording this. And so the day that you're watching this, the JUICE mission will be taking off. So it's so funny that you say, like, when are we going to have a mission to explore Europa? Yes. Now there's a mission going to Europa. I highly recommend you subscribe to my weekly email newsletter, and then you will get advance notice to all this kind of stuff. Go to university.com/newsletter. You're saying the audio level is low? Yeah, it is a little low. Maybe because I'm a little far away from my microphone. I should be closer to my microphone. Testing. Yeah, okay. Sorry. I know you're listening to that. Elise Nelson, do you know when we will see the next and newest images from Webb? We're getting new images from JWST all the time. Like every couple of days, we're getting new images. The most recent one, as the time that I'm recording this, was a really cool picture of the Cassiopeia A supernova, which is this fairly large cloud of debris that is moving outward ejected from a supernova that happened about 11,000 years ago. And you're seeing this kind of expanding sphere of wreckage in the sky. And we've got many pictures from other telescopes, Hubble, but we got the new images from JWST. And what you got from this image was you can see where before the star died, it blasted out a bunch of, shells of material into the space around it. And so then when the star actually detonated as a supernova, this shock wave went out and compressed these shells and threw a lot of material out of the supernova into this surrounding previously sent out wreckage. And so you've got these really cool kind of twists and twirls in the nebula as this material is colliding together. It's a really fantastic image. And we're getting these all the time. I would say we get a new interesting image coming from JWST every 3 or 4 days that we are reporting on at Universe Today. And if you watch the Space Bites episodes that we do every week, we typically will cover them. Oh, Uranus. We got some new images from Uranus last week. So last week we got Cass A and Uranus, and that's 1 week. And so I would say that's the cycle. Now, JWST is taking a ton of pictures. It's taking multiple science targets pretty much every single day. In some cases, it's only being used for an hour. In other cases, it's working for an entire day on some target. And right now, most of these targets are being sent directly to the astronomers who requested the time on JWST. They're reviewing the images, the data that they acquired, and they will be able to write their science papers. But a lot of other stuff is just released publicly immediately as it's done. And there's a great community of amateur image processors, people like Judy Schmidt and others who watch as these data sources are filled with new images from JWST, and then they bring them into Photoshop and try to pull out the interesting image out of the astronomical data. So all the time, there's new pictures coming out. So, all I can say is I highly recommend that you subscribe to this channel, because I will tell you every single time there's a cool new picture that comes out of JWST. That was it. Mage Matthews, where are we on the asteroid mining race? Who do you think will win? If there were to team up together, do you think the plausible process to make it happen would be? Where we are on the asteroid mining race is that anyone who starts an asteroid mining company goes out of business. That's where we are. There is no race. There is only going out of business. And that's because there's just no infrastructure. There's no viable way to get out to an asteroid, to survey, to find out what's there, to extract the resources that you require, and to bring them back to Earth or anything in any way or form that we can then use. There's nothing. And probably for the next couple of decades, it's going to be the same thing. We will see things start to change when there is some kind of space infrastructure, whether it is like a base on the moon where astronauts are harvesting local resources, or whether there is some kind of refueling in space, or some kind of 3D manufacturing or something that is using materials in space. So for the people who, and like there's a bunch of them, like I could list off 5 or 6 companies that have gone out of business in the last decade because they tried to start a space mining business. And if you want to start a space mining business, that is a good way for you to lose all your money. But there will come a day when we have the infrastructure, when we are regularly going to space, when we are needing those kinds of resources in space, and the space mining companies will have their renaissance, and this time the industry will stick around. Right? It's just so easy to just dig in the ground. Like, it's right there. You're standing on it. That's where the stuff is. Jason D. Will the Kessler syndrome eventually lead to a coherent ring around the Earth, or will the satellites fall out of orbit before this can happen? So the Kessler syndrome is this theorized point where all of the space junk that is orbiting around the Earth crashes into each other and turns into smaller and smaller pieces, and eventually all you've got around the Earth is just this buzzing, whirling sphere of metal moving at 28,000 kilometers per hour. And you can imagine then any attempt to fly a spacecraft out of the Earth just passes through this grinder and just gets turned in dust and added to the space debris problem. And that's not exactly accurate. There are many different orbits. There's stuff that's low Earth orbit where you're just like, say, 500 kilometers above the surface of the Earth. There's orbits where you're like 1,000 kilometers above the surface of the Earth. And then you've got orbits where you are more than that, 2,000, as well as you're in geostationary orbit where you're like 35,000 kilometers away from the Earth. And each one of these orbits has a length of time that the material is going to remain in orbit before it re-enters the Earth's atmosphere. So the stuff that's down around 500 kilometers above the Earth, it's still interacting with the atmosphere that a spacecraft at that altitude will return to the Earth within just a couple of years. You get up to 1,000 kilometers, and now you're looking at like a couple of decades. And you get up to 2,000 kilometers, and now you're looking at a few hundred, if not a few thousand years. But the distances between the objects get bigger and bigger. And so the stuff that is in low Earth orbit is very close. The stuff that's in higher orbits is farther away from each other, and so on. And so you could imagine material sort of crashing into other material at a low orbit, but then that material is going to re-enter the Earth's atmosphere and really clean itself out. And so there's no way to maintain a debris sphere in low Earth orbit. It's the higher orbits where it's a bit of a problem. But then because of the increased space in between the objects, you're probably never going to get to this point where space is impassable. It's just that it's going to be a friction, that you're going to lose spacecraft from time to time because there's more and more space debris in that region. And you might get to a point where the risks to your spacecraft are so great that you're not willing to put a spacecraft into 1,000 kilometer orbit or a 2,000 kilometer orbit, that you're just not willing to pay the insurance costs when there's a 1 in 10 chance every year that your spacecraft is going to be destroyed by space debris. But we'll still be able to get out. We'll still be able to launch on our rocket, be able to fly through the region in just a few minutes and get out into deep space again. So really the risk is an increased ongoing expense for operating spacecraft within those orbital spheres. And so it will never turn into a coherent ring because the satellites are all in different orbits. Some are on polar orbits, some are in equatorial orbits, and they could collide with each other, and then the debris is going to go in different areas, and so you're going to have this debris in more of a cloud. But there will be some regions that are denser and have more debris, and so we may get to a point where if you want to have the safest exit from planet Earth, you take a flight trajectory that carries you, say, above the most dangerous parts of the Kessler cloud to get out into deep space. But let's hope we don't reach that point. Just clean up after yourselves, everybody. Fraser, you make me think back to the 2012 Google Hangouts. Saturday night virtual star parties is such a great memory. Thank you. I want to bring them back. I have plans. So don't say never. Those are the days. Uh, John, are the mosquitoes as bad in your area as they are north of Toronto? No, we have very few mosquitoes here. That's kind of what makes it magic about this place, is that it gets so dry in the summertime that the mosquito problem is fairly minimal, unless you're like in places with lots of standing water. But like most of the time, you will be annoyed by the occasional mosquito. Nothing like they've got in the rest of Canada, or the black flies. Always the black flies. Everywhere you go, die with the black flies picking your bones. North Ontario. Mr. Monocle. Hey, Fraser, it's a known fact that these galaxies are all moving away from each other at an accelerating speed. I was wondering, how big, how small does this phenomenon go? So the phenomenon you're talking about is dark energy, this idea that the expansion of the universe, or I guess the distances that are growing in between galaxy clusters, is accelerating. And you're exactly right that for, if you have two galaxy clusters that are far apart and they're already, say, 1 billion light years apart, and they are drifting away from each other with the leftover momentum from the Big Bang, they're also accelerating away from each other thanks to this repulsive dark energy force that is entering the universe and sort of pushing objects away from each other. But we know that dark energy isn't going to pull the Earth apart. It's not going to pull the solar system apart. It's not even going to pull the galaxy apart. So where is that line? And it is somewhere in between the sort of the local group size and the supercluster size. So we know that here in the Milky Way, we have the Andromeda Galaxy that's coming towards us. We know there's M33. There's all these other dwarf galaxies that are surrounding us. And this is the local group. And the local group is a part of a larger group of galaxies known as the Virgo supercluster. But we're not actually bound gravitationally to the other objects in the Virgo supercluster. They are moving away from us. We will never merge with those galaxies, and they are also accelerating away from us. And so there is this perfect balance point. Like, it's farther away than Andromeda, but it's closer than, I don't know, M87, right? Some galaxy. So somewhere in that gap, there's like the perfect place that if you plopped a galaxy there, it would drift towards the Milky Way and merge with Andromeda, the Milky Way, and M33. But if you were like a little farther away, then the expansive force of dark energy would carry it away, accelerating it away over the cosmic horizon, never to be seen again. And, it is in the tens of millions of light years. So number is the distance to where you've got that balancing point between gravity pulling things together and dark energy pulling things apart. Time is it? All right, I think we've got time for one more. And then we'll go into overtime. Mike Null, where do you get your news from? So, my job as the publisher of Universe Today is I find the news for the writers. Now, the writers at Universe Today, they can write whatever they want, and many do. Many have news sources, they have people that they talk to, and they will write stories based on news and tips and things like that. But also, like, a large part of the news that you see on Universe Today is coming from me. And the way I do this is that I have cultivated an enormous set of news sources, probably a few thousand at this point. And they are very common ones that you're going to find, like NASA press releases coming from the European Space Agency, the European Southern Observatory, a lot of these places that everybody sees. And then there's less common places, like I look for space-related news coming out of all the different universities around the world. And then I look at technical journals. So like you've got the Journal of Astrophysics, you've got Acta Astronautica, you've got the Journal of Astrobiology. And so, they'll publish new journal articles every like month or so usually. And then I'll sort of look through the list of contents and see if any of them are stories we want to cover on Universe Today. I look at Archive, which is like the pre-print location for space news. Researchers will often do some research. They'll post their paper to Archive. Other people will take a look at it, give them feedback, and then they'll submit that to a journal. And so it can show up in a proper journal a couple of months later. But I like this stuff at Archive. And it's kind of risky because it hasn't gone through a journal yet, but I can handle it. I look at the news that is coming out of conferences. So you've got the American Astronomical Society meeting, you've got the Geophysics Union meeting. There's probably about 20 different conferences that happen around the world, and I will stay on top of those. And those are tricky because I'm not at the conference, and so I often, I can't see the presentation made by the scientists, but I'm able to sort of see the presentation that they gave, and then I can do follow-up questions and talk to them. I have sources. So, I have lots and lots of people who reach out to me with news that, either in a very formalized way, like they've got a press release for the company they're working for, or, they're a contact who works at NASA or at some other space agency, and they're letting me know some research that they're working on. So I look at social media, although I don't get a lot of material from social media. I find it's too late. But in some cases, like if there's some new piece of breaking news, sometimes scientists will write multi-part tweets about that news, and it's very helpful and interesting. How else do I find news? So I have this big list, and then every day I start at the beginning and I go through the list and go, what's new? And then I find all the stuff that's new and I throw it into this database for the writers to look through, and they claim the stories that they want to work on, and then they write them, and then we have a new day and I find more stories, and it just goes on and on and on. And like, it's not like I'm a control freak, but like there are a lot of stories that I'm really interested and curious about. And that tends to set the tone for Universe Today, where I'm really interested in cool new missions, ideas that think outside the box, new astronomical discoveries, especially ones that solve out long-standing mysteries in space and cosmology and things like that. I'm a lot less interested in rocket launches. You won't see a lot of that on Universe Today unless it's like the first launch of a new kind of rocket. There's lots of other people that do that. And there's lots of great YouTube channels here that'll give you every single update to the Boca Chica facility. I'm not interested in that, and so I don't cover it. So yeah, that's how I get my news. And like, I've been curating this list for 25 years, just every day going through the same list. What's new, and getting better and better and better at finding news stories. So, all right. We've reached the hour. So let's, I'm going to record all my outro stuff, and then we'll stick around and we will do overtime. Wow, lots of questions left over. Okay. So don't go anywhere. We've only reached halfway. If you like my answers to your questions, as well as the other things that we do at Universe Today, consider joining our Patreon club. This allows us to keep the minimum ads for everybody. Like, as you can see, there are no ads during the video. And as a patron, you'll get an ad-free experience on universetoday.com for life, even if you unsubscribe. You'll get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. Thanks to everyone who has already subscribed, and welcome to the recent newcomers: Scott Evers, Jimmy Jong, Richard Alton, Chris Ediger, Ishay Oz, John D. Sostrom, Jesper Peterson, George Service, and John Gannon. Join the club at patreon.com/universe today. All right, those are all the questions that we had today. Thank you, everyone, for asking your questions in the YouTube comments. And thanks to everybody who showed up for the live show, Monday, 5 p.m. Pacific time. All right, those are all the questions. Don't forget to vote, and we'll see you next week. If you want to stay on top of all the important space news, join my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word. There are no ads, and it's absolutely free. Subscribe at university.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at university.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to David Gilton and Maud So, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verbioff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. And then I've got to do the... There are no answered questions yet. Why doesn't that work? All right, I got to do my intro. If you're watching this, Chad, when I click the answered questions, it says, oh, when I go to the second page, then it gives me answered questions. All right. What is the biggest rocky planet? Why is the moon floating away? Will there be glass domes on Mars? All right. How big is the biggest rocky planet? Could you have a planet made of iron? Why is the moon floating away while Mars's moon is falling down? All this and more in this week's question show. Okay. All right. Thirsty? I'm kind of hot. Let me take off my sweater. And I'm going to open the window. Let's go open the window. That'll probably do the trick. Okay. Nice the outro in normal speed and not like Anton Petrov who rushes through at double speed. It's possible that I rushed through my outro at double speed, and Nancy has told me a couple of times to settle down. All right. So we're gonna go into. All right. Let me stop the recordings. Okay, and then let's go into overtime. The Cosmos LP. Yeah. Can you see it? Is it falling over right now? Oh no! I had to move my... It's actually not the... It's the Pioneer plaque. Was that in Cosmos? So somebody made this for me. And it's like an etching of the Pioneer plaque. Nobody talks as fast as Amy Shear title. Just like that in real life. Okay. Jonathan Allen, how come you never get interviewed? Surely people must ask you. If you sign up to my podcast, I post all of the interviews that people do with me, and they happen all the time. Like, I I can't even think. Like I would say there's probably 10 of them in the last year. And they're very different. Like I think the thing that you would find about the interview with me on the podcast channel is that they're quite, they're more into me explaining my philosophies about being a journalist and news and things like that. Stuff that I don't really get into. Moonwalker, what's for dinner, Fraser? So I'm experimenting with making roti, which are like lentil flatbreads. So they're kind of like tortillas, but they're made of lentils. And I got one of those high-speed blenders, and it's the best. Like the Vitamix ones, they're crazy. You can make soup, hot soup in the blender because it blends so quickly that the soup heats up and eventually it's just hot. These things are crazy. So, but yeah, they're really good. And so it's like a really high protein version of a tortilla, and they're good. Gumby 2MS. Ever try to get Mike Brown for an interview about Lucy and Planet 9? I've interviewed Mike Brown in the past. If you search on my channel, you'll find my Mike Brown interview, but it's a long time ago. I also interviewed him and Konstantin Batygin on the Weekly Space Hangout, which is out there still. And then, but okay, so I'm going to give you a sneak preview of something. So there is a really exciting paper that came out last week, and we covered it, or maybe we haven't covered it on Universe Today yet. I know one of the writers is working on it right now. But the principal investigator is Slava Turishev. He's the same guy who came up with the solar gravitational lens. And then you've got Mike Brown and Konstantin Batygin. You've got Alan Stern. You've got Carolyn Porco. You've got all of Andreas Hein. You've got all these members from the Interstellar Society. Like, it's a who's who of outer solar system explorers and propulsion specialists. And they are proposing sort of a new fleet of solar sail probes that will explore the solar system, doing a sun dive. So they'll go down towards the sun, pick up a lot of acceleration, and then blast out across the solar system. And we could see them all across, exploring every interesting object across the solar system in a fraction of the time, and go out to the solar gravitational lens. So I'm interviewing Slava on Friday, and this is like the second time I've talked to Dr. Turishev. And so, if you want to listen to the whole interview about the solar gravitational lens, that's on my channel. I feel like I'm just constantly referencing stuff I've already done. If someone can suggest a way that should I make we already have playlists. Should I make the best? What would that be like? What would that be? To give somebody just the core, most interesting stuff that I've done. Anyway, so I'm interviewing him on Friday, and we will talk about this idea as well as any updates on the solar gravitational lens. So I know you're all excited about that. So hang tough. It's coming very soon. It'll come out to the patrons first, and then it'll come out to everybody else. Jefferson Miranda, are we actually the universe trying to learn from itself? Yeah, we are. I think so. I think that's, the Carl Sagan's quote that intelligent life is the way for the universe to observe itself. And, you think about the ages of the universe. At the beginning, you just had random collections of matter and energy that gravity would pull matter together, and then other gravity would pull it apart and things would explode, and you didn't really have any rhyme or reason, and things weren't that interesting. And then life formed. And now you've got an actual life, you've got this process through natural selection that is sort of forcing more complexity over time. And here we are on Earth, we see the result of that. I mean, we've got trees, and we've got insects, and we've got whales, and we've got animals in every single ecosystem across Earth. And that is vastly more interesting than rocks and light. But then you got human brains. And so now we have, I hate to use the term intelligent design, but we have a world that is partly the result of evolution, natural selection, and then partly sort of an intelligence driven process where human beings are making roads and cars and buildings and airports and satellites and all that kind of stuff. And so part of the planet is the natural evolutionary state, and part of the planet is technology from an intelligent thing. But as we create artificial intelligence, and as the artificial intelligence makes more things for us, then more and more of our planet and eventually the universe will be driven by intelligence. That there will be that everything will be designed. It sounds really religious, but anyway, everything will be designed that, but done right this time. But everything will be designed that you will, and you take that to its like logical extreme, and you can imagine like the positions of stars, the locations of planets, the positioning of supermassive black holes. Like everything is malleable as long as it adheres to the laws of physics. You can imagine of some future incredibly intelligent civilization turning more and more of the universe into a more intelligently designed structure. And what will we lose from that? We'll lose the balls of dirt and rock and in the energy of the stars. That's all random, and we'll lose the evolutionary process over time. Like maybe there will be this garden, Earth will remain, and then the rest of the universe will be machines and humanity, hopefully working hand in hand to build space stations and terraform and habitats and all kinds of stuff. So it's a interesting time that we live in today, where we are right on the cusp of that process. Bravo 1, is Babylon 5 a good TV show? Yes, it's a great show. So Richard R., I'd love to see him make a compilation video on specific topics he's covered over time, picking from interviews, podcasts, space bites, etc. So part of the idea with the ChatGPT that we're going to do is I want to create a search engine that goes into the chat, and so you guys can command it, and you can say something like, if somebody says like, what's a Lagrange point, then those in the know can type in like, something like Lagrange with a command in front of it, and then boom, there'll be a couple of links will be dropped into the chat that then people can go and check out on their own. Jonathan Allen, when will the space orcs invade the Earth? Man. So, all right, do you want to hear something crazy? Something that I don't think any of you know is that I used to work for Games Workshop. So, which is, the company that makes Warhammer 40K and Warhammer Fantasy Battle and all that kind of stuff. So in Vancouver, there was a Games Workshop store. I don't know if it still exists, but anyway, and I worked there for a couple of years, teaching people how to paint figures, and we would set up. We had a big sort of gaming table in the middle of the store, and people would show up, and we would run demos and play games with them and teach them how to play Warhammer and all that kind of stuff. And then we'd sit around and paint figures and sell figures. It was a lot of fun. So Chaos Space Marine for the win. There you go. Yeah, I like the Harlequins. They were fun because you didn't have to go and paint an enormous army. You could just paint this tiny little army of people that were way overpowered, and that was a lot of fun. Dean C., what do you think of Space Force? I think it's fine. It's a logical name for a one arm of the U.S. military that is focused on the assets that are in space or deal with space. And before Space Force was created, they were kind of all over the place. Like there was little bits of reconnaissance done through the Air Force. There was bits done through the Army. There was bits just done through the National Reconnaissance Office. And so it makes sense to bring it all together under one system. But like Space Force is such a misnomer. Like you imagine Space Marines hopping on board their space battleship and flying off to fight the space orcs, when the reality is that they're people who go to offices and look at satellite data and plan missions to observe the Earth. So the Dean C is saying, I don't think it's good to have military in space. Sure, but space is militarized to the maximum amount that is permitted by the Outer Space Treaty and makes sense. So there are hundreds of satellites in orbit that have some military capacity, but it's not like nuclear missiles. You're not allowed to have nuclear missiles in space. It's not space lasers. It is communication systems. It is, GPS. It is weather satellites. It is secure methods for coordinating troop movements. It is reconnaissance satellites in space. It's not good until the space orcs show up. Yeah, obviously, if we knew the space orcs were coming, we would have the space battleship with the space marines. That's one of those lessons that we will learn later on. And the space orcs paint their spaceships red because red goes faster. Elise and Nelson, are you looking at the planet lineup tonight? I'm guessing. I can't. So where I live, I have a really bad view to the west. And so I can see Venus just poking up above the treetops. And then I can't really see any other planets lining up. So unfortunately, no, I'm not going to be observing the planetary lineup. Dean C., what do you think of the Crash Course Astronomy series? It's good. It's Phil Plait. How can it not be great? Phil Plait and I have a long history together, good friends. We used to run a discussion forum together, which has now been merged over with CosmoQuest. But yeah, no, we've done lots of projects together. And Phil's the best. Phil, like when I think about all the people who kind of influenced my style, Phil Plait was one of the people who was already going when I was just starting Universe Today, like 25 years ago. He had already been reporting space stuff for a couple of years. And he was, he really helped me build my skeptic mindset about various astronomical theories and pseudoscience. And, he had already been battling the Planet X Nibiru debate for years. Like we still are 25 years later. Like, it's not coming. It's not a thing. But yeah, no, so huge props to Phil Plait. If you haven't checked out his column, The Bad Astronomer, but more importantly, check out his Substack. He does a really great newsletter that comes out once a week, and I highly recommend it. So Phil Plait, The Bad Astronomer. The Who Knocks. Just when you thought Fraser was cool, then we worked for Brain Exploded. All right, I'll tell you the cool things that I've done in my life. All right, and partly it's just because I'm old. Like, keep that in mind. So I played the first prototype of Magic the Gathering. I was in a group of people. We went to, oh my God, what do you call it? Gen Con. So we drove to Gen Con in a bus with the people from Wizards of the Coast. And this was before they had released Magic the Gathering. They're out of Seattle. And I was friends with the people at Wizards of the Coast. And so they were like, do you want to go to Gen Con? We're going to we're going to rent a van. We're all going to go together. I'm like, yeah. And he's like, okay, great. And we're going to, and while we were on the trip, they're like, we've got one of our developers has developed this new game. It's called Magic the Gathering. Do you want to give it a shot? Do you want to try it? And it was like paper cards with, like Garfield on it and things like that, but it had like the mana and had the different kinds of land, and we would and we played the game, and I was just like, this is the greatest thing ever. Like if I don't know if you've seen that new Tetris movie, but it's very much like, you're like, this is going to be gigantic. I happened to be working at a game store at the time, a different game store, and so when we got back to home, I put in a gigantic order for the second Magic, the Gathering came out, and then sold them tons of them, and had a great collection of Magic the Gathering cards. Where's my Magic the Gathering cards? I have a giant box of Magic the Gathering cards. Anyway, it's back there. Maybe it's still in storage. But I had like a Black Lotus that I sold a couple of years ago. Well, a long time ago. Anyway, so that's cool thing number one. Cool thing number two, as I said, I worked at Games Workshop. I wrote multiple books for Shadowrun and for Earth Dawn. Do I have those books? Yeah. Let's see. So if you play Shadowrun, right? So here's the double exposure Shadowrun adventure. There's my name at the bottom, right there, with Nigel Findlay. And then there's essentially the monster manual for Earth Dawn. And there's me right there. So that's cool. What else did I do that was cool? That the kids would enjoy. I guess that's it. Is Magic the Gathering cool? I guess not. Maybe it isn't. Maybe to a certain group of people it is. But yeah, so like 30 years ago-ish, I was pretty deep in, like I very well could have been a role-playing game writer. Probably would have ended up being a video game designer. Like that was sort of the path I was going. So it's sort of surprising that I ended up in the place that I did. Let's see. I'm gonna grab a couple more questions and then. Serious Killy, did you not witness a rocket launch in real life? Yeah, absolutely. I saw the launch of the Osiris-Rex mission, and the Osiris-Rex capsule is coming back to Earth in like another year, and I would love to be able to report on the capsule and sort of like I saw the rocket take off, and I'd love to be there and see the capsule brought back or opened up. That would be really neat. Let's see. What else did I do that was interesting? And I went and saw the space shuttle, but I didn't see it launch. So I got a chance to get up close to the space shuttle, but I didn't get a chance to see it launch. I guess that's it. All right. Well, I think at this point I'm going to wrap things up. So thank you, everyone, for joining today. I really appreciate it. Thank you to all of the mods for gathering all of the questions so that I can sort of hammer through them as quickly as possible. I really appreciate it. Thank you to just all the other mods who stayed on top of the comments. And thanks for everyone who just comes and hangs out. This is a lot of fun. Every Monday. I really look forward to this. And like I could do this for hours, but I have a life. I got to get out. So, all right. Thanks, everyone. And look forward to those new interviews. And we'll see you all next week. Where is the button?